Hello friends, welcome to Susan and John MathTube. In this video, we continue our discussion on higher order derivatives. And in this video, we will learn how to find the general derivative or the nth order derivative of product functions. And we will use Leibniz theorem for derivatives to find the general derivative of product functions. Anyway, let's start with one example. Okay, you can write the question. I hope all of you are ready with pen and paper. So the question goes like this. If y is equal to a sin log x plus b cos log x, if you want you can put brackets, then prove that. Okay, the first part is what we learned in the last video of higher order derivatives. So prove that x square into y2 plus x into y1 plus y equal to 0. In the last video, we learned a trick. So that we will get this expression really fast. Okay, now the second part, that is related to Leibniz theorem. Hence prove that x square yn plus 2 plus 2n plus 1 into x yn plus 1 plus n square plus 1 into yn is equal to 0. Okay, anyway, let's start with the first part. And remember, those who have not watched the last video, I will strongly recommend pause the video right now and watch the last video so that you will feel comfortable when I do the first part. Anyway, in the last video, the trick was to identify the three enemies. Okay, so look at this expression. We can see y, which is the given function, y1 the first order derivative, and y2 the second order derivative. So what we do is we will find y1. Look at this, capital A, capital B, A, B, C, if not specified, will be treated as constants. So capital A into, now we have a function of a function. Look at this, the derivative of sin x will be cos x. But the derivative of sin something is cos the same thing times derivative of that something part. So sin log x, the derivative will be cos log x times 1 by x. We'll put a big plus. Now the second term. So keep b as such. Again I can see a function of a function or a chain function. Cos something. Cos something, the derivative is minus sin the same thing, of course, times 1 by x. Okay, now I told you in the last video, after differentiating once, you should check the expression in the sense the first derivative for three enemies. Well, the first one is fraction, the second one is square root, and the third one, you should check whether the question repeats itself or not. Because you know that when you differentiate sin will become cos and cos will again become minus sin. Anyway, that sign will be same. When you differentiate exponential function, you get the same thing. Okay, once more I will tell you, we have to check this expression for fractions, square root, and you have to check whether the given question itself appeared or not. Anyway, I see one enemy, that is our fraction. I can see x in the denominator. Okay, it's very easy. Let's get rid of that x. Multiply throughout by x. So we get x into y1 is equal to a cos log x minus b sin log x. So what I did is I'm multiplying term by term with x on both sides. Okay, now I don't see any more enemies because I told you enemies are fractions, square root and the given question. Okay, since it is free of enemies, we will differentiate this again, because if you look at the question, you can understand that we have to differentiate this 2 times. Okay, so you can write the next dialogue, differentiating again with respect to x. Okay, here we go. So we have to apply product rule here. So x into y2 plus y1 into 1. So look at this. We have to apply product rule here. X into y2 plus y1 into 1 is equal to same type of differentiation. A into, you already saw what happens to cos log x times 1 by x minus b into cos log x into 1 by x. Once differentiation is complete, you have to check for the enemies again. First enemy, fraction. I see fractions over here. So multiply throughout by x. So I get x square into y2 plus x into y1 is equal to minus a sin log x minus b cos log x. I'll take this minus outside, so I end up with, okay. Now look at this. Fractions are gone and no square root. Now let me check one more thing. I can see that this part. Can you see the question? A sin log x plus b cos log x. I see the same thing here, a sin log x plus b cos log x. Now, if the question returns, you have to do is, you have to replace it with y. That's it. So we get x square into y2 plus x into y1 equal to minus y. Or in other words, we proved the first part. Now we are going to apply Leibniz rule. But remember, before applying Leibniz rule, it is compulsory that in a product of 2 functions, the function which will disappear after a few derivatives should be taken as the second function. Look at this. The derivative of y2 is y3, y4, y5, y6, y7, y8. It goes on like that. But when you differentiate x square, you get 2x. 2x becomes 2, and then if you differentiate, it becomes 0. So look at this. When you apply Leibniz rule for a product, make sure the function which will disappear after a few differentiations is taken as the second function. Now let's take a look at the next product. So I'm going to make it y1 into x equal to 0. Okay, for those who do not know Leibniz rule, you can imagine we have 2 functions in x, u and v. And let's say you're looking for the nth derivative. The formula is very simple to apply. You write un, that means the nth derivative of the first function, and the second function as such, plus you can write n. It is actually NC1. NC1 is n. And then what you do is you write the n minus 1th derivative. That is very, very simple. You just change n into n minus 1. And then differentiate the second function. Now remember, the second function will disappear after a few derivatives. Or when you differentiate the second function for 3-4 times, or maybe 10 times, or maybe 20 times, or maybe finite number of times, that will disappear. Okay, and the next term, always remember, term means separated by plus or minus. So the next term is NC2. Actually, NC2 is nothing but n minus 1 in the numerator and 1 into 2 in the denominator. Okay, now what you do is you reduce n into n minus 2 and then differentiate the second function again. And again it will be n minus 1, n minus 2 by 1 into 2 into 3 u n minus 3 v3, and it keeps on going like this. Okay, now let's try it out. So look at this. Let's say we have x square into y2. You have to understand one thing. The derivative of y is denoted by y1. y1 differentiated gives you y2. y2 differentiated gives you y3. y3 differentiated gives you y4, etc., etc. And you will notice one thing. If you differentiate y1 2 times, you are getting y3. That is kind of like adding that index. Once more I will tell you. Suppose you differentiate y2 2 times. You are going to get y4, right? First time this, second time this. That means if you differentiate y2 3 times, let's see what happens. We will get y3, y4, y5. Oh, that was very easy. All you have to do is you write y2 plus 3. Now I'll come to my point. If you differentiate y2 n number of times, you're going to get y2 plus n. 2 plus n is the same as n plus 2 and it looks better. Okay, so with that knowledge, we are going to apply Leibniz theorem for the product x square into y2. Now look at this. This second function has non-stop derivatives. y3, y4, y5, y6, y7, y8. So this should not be the second function, because I warned you, if you want to apply Leibniz rule or Leibniz theorem for derivatives, the function which will disappear in a few differentiations should be written as the second function. Okay, now let's start. It's very easy. Write the nth derivative of the first function, that is yn plus 2. I told you why it becomes yn plus 2. And you write the second function as such. I hope you remember the rule, u into v differentiated n times gives un into v. You write the same thing. Now the second term begins with n. Actually n comes from our NC1. And then you reduce, you look at the first function and reduce 1. You subtract 1 so that you get n plus 1. And differentiate the second function. See, that explains the second term. N minus 1 v1. Now do you remember what was the third term? The third term is n minus 1 in the numerator, and denominator will be 1 into 2. and again you reduce 1, that is yn, and differentiate the second function. Okay, that's it. That's it. The reason is, if you apply this once more, okay, let's give it a try. Next will be n minus 1, n minus 2, by 1 into 2 into 3, y n minus 1, and the derivative will be 0. Okay, so this is how we apply Leibniz theorem. Now let's start working out with the problem, and I'm sure that your confusions will be cleared when we do a few problems. Okay, now in exam it is very important that you write differentiating n times with respect to x using Leibniz theorem. And what I saw in your past year question papers is now and then they ask statement of Leibniz theorem. So you can check your reference book or any book you like and by heart the theorem. Okay, now look at this. I'm going to apply Leibniz theorem term by term. So look at this. Can you see a product? Okay. So let's start. y2 becomes, what should I do with the first term? I should write the nth derivative. And I told you it is very easy to write the nth derivative. All you have to do is you have to add n to that suffix. Okay, now write the same function, the second function as such. Plus, don't forget n. And then what should I do with the next thing? I should reduce 1. n plus 2 minus 1 will be n plus 1. What should I do with the next quantity? Yeah, differentiate. That's it. Now again I'll put a plus sign. Now this n becomes n minus 1 by 1 into 2. And what should I do with this? Yeah, I have to reduce 1. So n plus 1 minus 1 will be yn. Now 2x becomes 2 into 1. That's it. That's it. You can stop applying Leibniz theorem once the second function becomes a constant. Because in the next term, the derivative of constant will be 0. So the next term onwards, everything will become plus 0, plus 0, plus 0, plus 0. Okay. Now let's go for the second term. Okay. So I'm going to put plus. Tell me, what will be the nth derivative of y1? That will be very simple, y1 plus n. So I'm going to write yn plus 1. I prefer writing n plus 1 than 1 plus n. Both means the same, but I don't know why, but I like this. And I have to write the second function as such. Plus, what should I write next? N. Now I reduce 1 from here and I differentiate the second function. Oh wow, the second function became a constant. Stop. Now for the third term. The third term is not a product. Notice the third term is not a product. So we cannot apply Leibniz theorem. Leibniz theorem will be applied only for products where one of the function will vanish after a few differentiations. But nothing to worry. What is the nth derivative of y? Of course, the nth derivative of y is yn. So the last term becomes yn equal to 0. That's it. Now we'll do a lot of examples so that you become familiar with this. Now it's very easy. Cut. Okay, now look at this. The trick is, first you have to collect yn plus 2 terms. I'll repeat. First you have to collect terms with yn plus 2. So I'm going to write x square into yn plus 2. Next you have to collect yn plus 1 terms. So that will be this. And remember, in most of the questions, They will always ask prove that question. So you can check the question and you will see that in most of the questions x into yn plus 1 will be common. You can see that x into yn plus 1 is common, and the remaining part, in the first term it is 2 into n, and in this one it is 1. Okay, plus now you have to collect yn. Okay, yn means, I'll open this bracket and write n square minus n, and next one plus n, and next one plus 1. Wow, that's it. You can check the question and see. X square yn plus 2, 2n plus 1, n square plus 1. That's it. I hope you understood. Okay, now let's try one more question. Please write the second question. If y is equal to e to the power m sin inverse x. I'll repeat once more. Normally, the letters A, B, C up to L, M, N will be treated as constants unless otherwise specified. Okay, so if y is given by this, then prove that. Okay, again I have divided the question into two parts. 1 minus x square into y2 minus xy1 minus m square y equal to 0. And I'll again repeat, the first part is related to the last video. Those who didn't watch the last video, I'll strongly recommend pause this video right now and go for it. Okay, now the second part, that is the Leibniz theorem part. Prove that 1 minus x square y n plus 2 minus 2 n plus 1 x y n plus 1 plus n square plus m square into yn equal to 0. And as I told you in the last video, by looking at the first expression, I know that we need y, which is the given question. We need y1, we need y2. So don't think too much. Just differentiate with respect to x and find the first derivative, which we denote by y1. Are you able to see e to the power something? As I always tell you, if it is not e power x, and if it is e power something, we have to apply chain rule, which is very easy. E power something differentiated gives you e power the same thing multiplied by the derivative of the something part. Okay, so that gives you e power m sin inverse x times, we have a product here, but m is a constant, and the derivative of sin inverse x is 1 by root under 1 minus x square. Okay, now let's take a look at our enemies. Enemy number 1, fraction. Enemy number 2, square root. And enemy number 3, the given question pops up after differentiation. The given question pops up after differentiation. I can see that. Look at this. Our question is e power m sin inverse x, right? We got the same thing. So how do you deal with it? Very simple. E power m sin inverse x is y. So to replace it with y. So we get something like this. It is not free of enemies. I can see square root. If square root comes, we have to square each and every term. No, we are not free of enemies. We have a fraction. Okay, we can multiply throughout by that fraction, or you can imagine we are cross multiplying. Finally we are free of that enemies. So please write differentiating again with respect to x. So we get 1 minus x square into, at this point I'll strongly recommend you to watch the previous video, because in the previous video I explained very clearly how to differentiate y1 square. Okay, anyway, in this video I'm not going to explain. So something squared gives you 2y1, and y1 the derivative is y2. Plus we have to apply product rule. I think you can see the product u and v. Okay, so y1 squared into 0 minus 2x is equal to, now the derivative of the right hand side. M is a constant, so m squared is a constant. M is a constant, so m squared is a constant. Now the derivative of y squared, that will be 2y into y1. Okay, now I told you one more trick in the last video. That is, in most of the problems you can expect 2 to be a common factor. That is, I am dividing throughout by 2. And I am dividing throughout by y1. In most of the problems you can expect 2y1 to be common. That's it. We get the first part, 1 minus x square into y2 minus x into y1 minus m squared into y is equal to 0. You can confirm it exactly. Now the second part. Second part means we are going to apply Leibniz theorem. Remember, we have 3 terms here, term 1, term 2, term 3. And I'm going to rearrange so that we can apply Leibniz theorem. Why am I rearranging like this? Because if you want to apply Leibniz theorem, the second function should be a function which will vanish after a few differentiations. 1 minus x square will become minus 2x, and minus 2x will become minus 2, and then 0. Minus y1 into x minus m squared into y. Now look at this. This is a constant and this is y, and the derivative will be m squared into yn. So we are not going to apply Leibniz theorem for the last term. Now in your exam paper you should write applying Leibniz theorem term by term. So let's start with the first one. I hope you are able to see the product. Okay, so let's differentiate yn plus 2, because the nth derivative of the first term and the second function as such, and you have to write n. Now what should I do? I have to reduce n plus 2 into n plus 2 minus 1, that is n plus 1. And what should I do with the second function? Differentiate. Again plus. Now n becomes n minus 1 in the numerator. Denominator becomes 1 into 2. And the next function becomes yn. And the last one, the green one, differentiate once more. It becomes minus 2, which is a constant. So that means we can stop applying Leibniz theorem. Okay, now let's apply Leibniz theorem for the next second term. So I will color it just like before, blue and green. So let's start. So I'm going to put minus and brackets so that we don't make any mistakes. So let's start. So what happens to y1? y1 becomes yn plus 1, and the second function as such. I'll write with our color code. Okay, plus. Now what should I write? N, and the first function I have to reduce 1, and the second function should be differentiated. Oh, good news. The derivative of x is 1 and 1 is a constant. That's it. Okay, now the last term. The last term is not a product. I'll repeat. The last term is not a product in the sense it is not a product of variables. M squared is a constant, so I'm going to keep m squared and I will differentiate y. Y becomes y1, y2, y3, y4. The nth derivative will be yn, of course. That's it. Now it's all about rearranging things. Okay, so the first term 1 minus x squared into y n plus 2, and as I promised y n plus 1, but you can see that x will be always accompanying y n plus 1. In most of the problem it happens. I think I'll put plus and write x into y n plus 1 because in most of the problems I see that. Now minus is there, 2 is there, n is there, minus 2n, and here it will be minus 1. Now the last term, that is yn, 2 cancels, so yn minus is there, n minus 1, minus is there, minus is there. Lot of negative quantities, so we have to be extra careful. So we are going to get 1 minus x square into y n plus 2. Now minus comes outside, 2n plus 1 into x y n plus 1 plus yn into this minus goes inside, so we get minus n squared plus n minus m square. I think this minus will come outside. I think the prove that part was minus half. Please correct the question. It was minus half. I accidentally put a plus, but when I tried to prove, I'm not getting it. I just checked the question paper. It was minus half. I'll repeat. When I wrote the question earlier, there was a small error. I wrote plus here. Please correct it. So that's it, my friends. So I hope you understood how to apply Leibniz theorem. And remember, I checked a few question papers, and in most of the question papers, the first question was Leibniz theorem. In some question papers, they asked state Leibniz theorem, and then they asked to prove something like this. In some question papers, they divided it very clearly like part 1 and part 2. But sadly, in some question papers, they never gave this. That means, first of all, you have to derive it by yourself, and then you have to apply Leibniz theorem. Anyway, I'll be back with another video in which I'll be doing more questions from your past year question papers. So till then, my friends, bye. And by the way, if you like the video, please share, subscribe. So we'll meet soon. Till then, bye.